Alpha Centauri, our nearest star system, apparently sends objects in our direction. These microparticles are constantly entering our atmosphere, though we just haven't noticed them yet. Can you imagine that pebbles from the Alpha Centauri system are lying in our stream beds, or that a harmless-looking stone in the garden is, in fact, an extraterrestrial visitor? Scientists have now published an astonishing study for the first time about these interstellar visitors and their possible effects on our world. The latest research shows that material from the Alpha Centauri star system has already reached our solar system. The Alpha Centauri system is our closest neighbor, located just over 4 light-years away. It consists of 3 stars, Alpha Centauri A and B, which form a double-star pair, and Proxima Centauri, a dim red dwarf star. Not only is the entire system our galactic neighbor, but it is also constantly moving towards us at 22 kilometers per second, meaning a huge star system is approaching at 79,000 kilometers per hour. Researchers suspect that these movements and interactions are causing material transfers between our solar system and the Alpha Centauri system. New research methods now offer unique opportunities to study the exchange of material between star systems. The newly published study estimates that potentially large amounts of material from the Alpha Centauri system arrive in our solar system. Specifically, the authors suspect that these materials accumulate predominantly in our Oort cloud, a mysterious cloud located far outside the actual boundaries of our solar system. Until now, the Oort cloud was clearly attributed to our solar system, but researchers now propose that it could also have formed through an exchange of materials with the Alpha Centauri system. In addition to comets of various sizes, the cloud probably contains up to 1 million particles, ranging from tiny grains of dust or sand to objects over 100 meters in diameter. Due to their enormous distance from the Sun and their wide distribution, observing and researching the objects in the Oort cloud is a challenge. Astronomers suspect that the Oort cloud could serve as a collecting ring for interstellar objects, capturing space floaters and binding them long before they can enter our solar system. This would provide great protection, as free-floating space rocks or objects can become a danger within the solar system. Larger interstellar objects, such as Oumuamua and Comet Borisov, have attracted significant attention in recent years. These two are thought to be the first interstellar visitors to have penetrated the interior of the solar system, though in reality, they are probably just the first that we have noticed. Researchers suspect that, in addition to these larger objects, countless smaller objects enter the inner solar system every year and usually go unnoticed. The study showed that some material from Alpha Centauri most likely reaches our solar system all the time. Some of these objects could have a long journey behind them, with elliptical orbits, deflections, and the proper motion of the star systems and the galaxy causing some to travel for up to 10 million years. To survive the journey, these particles must be larger than about 10 micrometers. Researchers estimate that about 10 of these Alpha Centauri particles currently enter the Earth's atmosphere as visible meteors. Meteors are smaller rock units that often burn up or fall to Earth as small rocks when they enter the atmosphere. It's a fascinating assumption that rocks arriving here on our globe may have been traveling from the Alpha Centauri system for several million years. Researchers suspect that this material mixes with nature here as normal, and it would be a stroke of luck to find such an Alpha Centauri meteor and identify it conclusively. This raises the exciting question of how material from another solar system can affect our world. Researchers are unsure whether foreign rock and unknown minerals could have any influence on ecosystems, but it's almost certain that the rock has not been contaminated by its long journey through space and is probably not radioactive to a worrying degree. Over a period of 110 million years, about 1.9 million particles were ejected from Alpha Centauri, with only a small fraction, about 0.03%, coming close to our solar system. These simulations help scientists understand how material from other star systems can enter our solar system and what effects it could have. In summary, the research shows that a large amount of interstellar material from the Alpha Centauri system has reached our solar system and is likely already here, mostly in the form of smaller stones the size of pebbles or fist-sized lumps of rock. Although the probability of larger objects getting close to the Sun is low, researchers have simulated even the theoretical flight of such objects to understand the dynamics and whether the composition of star systems outside our own has an influence on our system. The discovery of Oumuamua and comet Borisov, two interstellar visitors, has been groundbreaking. Oumuamua, officially designated 1I our 2017 U1, was the first confirmed interstellar object to pass through our solar system. Discovered by the Pan-STARRS telescope in Hawaii on October 19, 2017, it had an unusual cigar-shaped form, measuring about 800 meters in length and 80 meters in diameter. It moved through the solar system at a speed of about 87.3 kilometers per second on a hyperbolic orbit. The real shock was that we only noticed the object after it had passed Earth by a hair's breadth. Oumuamua was truly unusual, a strange shape, an almost impossible trajectory, and no clear explanation of its origin or composition. Scientists have noticed that Oumuamua experienced a slight acceleration that cannot be explained by gravity, leading to theories that it could have been an artificial object, possibly even a probe from an extraterrestrial civilization. To this day, Oumuamua remains one of the greatest mysteries in astronomy and space exploration. Comet Borisov, discovered on August 30, 2019, by Russian amateur astronomer Gennady Borisov, was clearly an interstellar comet, making it the second confirmed interstellar object in our solar system. It raced towards the Sun at a speed of about 32 kilometers per second and reached its closest point to the Sun on December 8, 2019. Unlike Oumuamua, Borisov behaved like a typical comet, with a distinct coma and a tail of gas and dust. Spectral analysis showed a high concentration of carbon monoxide in its coma, leading researchers to conclude that it originated in a colder star system. Images from the Hubble Space Telescope show that this comet split into two large fragments before leaving our solar system. Its orbit revealed that it was never gravitationally bound to the Sun and only passed through our solar system, continuing its journey toward the constellation Telescopium. The question arises, could a comet or asteroid from the Alpha Centauri system hit us? It's considered almost certain that asteroids and comets exist not only in our solar system but throughout the universe. These rocky fragments are relics from the formation of suns and planets or debris from collisions. Since Alpha Centauri is our closest neighbor at only 4.37 light-years away, it's theoretically possible that a comet or asteroid from there could hit Earth one day. If Alpha Centauri has a comet system similar to our Oort cloud, collisions or close flybys of stars could hurl some of these objects into interstellar space. If one of these chunks happens to hit an orbit that takes it towards the solar system, it could eventually approach Earth. The advantage of interstellar asteroids and comets is their high speed and the fact that their orbits are not bound to the gravity of the Sun, making them move extremely fast and in very direct paths through our solar system. The first two officially confirmed interstellar objects, Oumuamua and Comet Borisov, were extremely fast, crossing our solar system at over 90,000 kilometers per hour, which makes a direct collision very unlikely.